A very warm welcome to this new video series on my channel where we are going to cover all the mathematics concepts required for deep learning, machine learning and data science. So the series is going to be covered in three segments actually. The first segment will consist of data probability and statistics. The second segment will consist of linear algebra, determinants, your matrices, etc. The third segment will be purely calculus. Now, the first segment and the second segment will be in this series, but the third segment will be covered in a separate series that I am planning to start. That will be the deep learning series, where we will start with deep learning, and in the way of covering deep learning, we'll dedicate one or two videos separately to calculus to understand how it works there. For these two segments, what we are going to do is first we'll use 3-4 videos to understand the concepts, and then a final video will come where we'll use NumPy or the required libraries to practically implement these concepts in our code. Now, this video is just an introductory video where we'll be getting familiar with the terminologies that we are going to use in the coming statistics and probability segment. Similar things will happen in the linear algebra also, where there will be an introductory video like this where we'll get familiar with basics. The second video will be a little faster, where we'll be covering everything. Like for example, here I have planned that in the next video only we'll start from central measures of central tendency, measures of dispersion, and we'll go to z-test, hypothesis testing in a single video only. Okay, and in third video we'll summarize everything, and in the fourth video there will be a practical implementation in our code. We'll take a data set and we'll perform the concepts in real world application. Okay, so that is going to be the structure of this entire series, how things are going to come up, and I hope that it is successful and we complete this series. So this is the first video. Welcome to the world of statistics and probability. Today we are just going to get familiar with the terminologies and basics of what statistics is, what are different kind of statistics, what is data, what are different types of measuring data, and how do you represent this data, what is the difference between a histogram and a bar graph. So we are going to look at all that things today. So let's begin. Let me minimize my face and let me share my screen. I hope my screen is visible. So first, what is statistics? Before learning, we should know what we are learning. So statistic is known as the science of collecting, organizing and analyzing data. Let me repeat. Statistics is the science of collecting, organizing and analyzing data. So from the definition itself, it's very clear what happens in statistics. We collect some data, we organize the data, and then we analyze the data and form some conclusion or get some answers to that data. And statistics is the base of machine learning and deep learning as well, because in machine learning and deep learning, what is happening? We are collecting a data, we are fitting a model into the data, and that model is analyzing the data and giving us an output. So statistics is the backbone of data science, machine learning, deep learning, data analytics, everything that you can think of. Okay, so statistics is very important to learn, and today we are going to learn what the basic terminologies. So there are two kind of statistics. One is called inferential statistics and the other one is called descriptive statistics. So first let's write down the definition that we just noted. That is, statistics is the science of collecting, organizing and analyzing data. So just write down that statistics is the science of collecting, organizing and analyzing data. So that is statistics. I'll share the notes with you guys too. You can find them in the description. Oh my god, what is happening? Yep, yeah. And now, what is probability? That our second topic for today. But we won't be covering probability in depth today. We'll be covering it in the next video. I'll tell you the reason in the next video why we'll be covering probability in the next video. But today we'll be focusing more on statistics. So what is probability? Probability is number of favorable outcomes by total number of outcomes. I hope everybody has studied probability in their earlier classes. I think it starts from class 7, 8 onwards. So number of favorable outcomes by total number of outcomes is probability. So what is the probability of Vishal getting selected into XYZ college? So the probability can be yes and no. So favorable outcomes. So for example, getting a yes, what is it? Number of outcomes is 1. Total number of outcomes is 2. So probability of Vishal getting selected is 1 by 2. Probability of Vishal getting not selected is also 1 by 2 because no is also 1. Okay. So, but for example, if there is a third probability that the probability is getting waitlisted. So the probability then total number of outcomes will become yes, no, waitlisted. So there are three. So the probability of getting yes will be 1 by 3, probability of getting no will be 1 by 3, and probability of getting waitlisted would be 1 by 3. So there are some things in probability like gambler's fallacy or probability density distribution. I thought of covering that today, but then I realized that it will be better if we covered it tomorrow in the next video, because then we can learn the distribution, the Gaussian distribution, the Poisson distribution, and then we can understand it through probability also. So that is why we are covering it tomorrow. Today we are focusing majorly on statistics. So statistics is the science of collecting, organizing and analyzing data. Till here everything is clear. So now statistics can be of two types. Okay. Statistics can be of two types. Let us note that down. Statistics can again be of two types. The first one is descriptive statistics, and the second one is inferential statistics. So what is the difference between descriptive statistics and inferential statistics? So uh, I have a photo to I found a photo online that will explain it better. Let me just copy paste that photo. Yeah. So here, wait a minute. Yeah. So what is descriptive statistics? This quantitatively describes the characteristics of a particular data set under study with the help of brief summary about the data. What is inferential statistics? Random sample is drawn from the large population from which the sample is taken. No need to get into those heavy words. Let me explain it to you in simple words. So what is descriptive statistics? Here we collect the data, organize the data, analyze the data. In inferential also we do the same thing. But what happens in descriptive statistics is we find out some value. Okay. We find out that in central tendency, we find out whether you see the value, what is the middlemost value of this data set, or in standard in dispersion we find out that from actual middle value how much is the coming middle value different. The difference between the actual mean or the actual median from what the median we are getting is. Okay. In For example, when there are outliers, what are outliers in a data set? For example, you are finding mean of marks. Okay. So I got 5, someone get 10, someone else got 15. So we are finding the mean. Okay, so 10 people are getting it between 10 to 20, and there is a 11th person which is getting like 100 marks out of. Okay, we are getting 10, 20, 15, 17, and that person is getting 100. Now, if we find the mean, it will not be a perfect mean because that 100 is an outlier. But that problem is not there when it comes to median. Okay. So all this mean, median, variance, standard deviation, these are all part of descriptive statistics where we are, uh, you know, uh, we are describing some characteristics about the data, like whether this what is the mean middlemost value, how much is differing. So these are all characteristics. But in inferential statistics, what is happening, we are drawing some conclusion. For example, we can take a data set of marks and we can calculate the mean or the median. But in differential statistics, in inferential statistics, what happen is we can ask a question like whether the average marks of this class is more than the average marks of the entire school. Okay. Now, what happens here? Entire school is known as population, and the marks scored by, say, class 11A is known as the sample. Okay, now I also have a photo for that. I'll also paste that so that it's easy for you to understand. So, yeah, copy. So, descriptive and inferential. So, from here we get inferential is a conclusion. Okay, a conclusion that we draw. A conclusion that we draw is known as inferential statistics. From a data set, we are drawing a conclusion. Okay, so here also it is written to draw conclusion of the data obtained. Okay, and it results in probability scores. So again, I ask you whether if the marks scored by 11A is more than the marks scored average marks scored in the entire school. That is a part of inferential statistics. So here the value will be yes or no. Again, yes and no is 1 by 2, 1 by 2. That is, it is coming in probability scores. Okay, so that is what inferential statistics is. And inferential statistics, the example can be z-score, hypothesis testing, whereas the descriptive statistics, it can be the measures of central tendency, measures of dispersion. So you understand what is the difference between descriptive and inferential statistics. Now let's see what population and sample size are. Okay, so wait a minute. Where did the photo go? Let me just find the photo. Yep, I got the photo. Copy. Differences between inferential statistics. Next topic we have is population versus sample. So let me explain to you this again with the help of an image. Okay. So for example, now this can be entire school, entire school, and this can be class 11A, 11A. So again, through this earlier concept of inferential and descriptive statistics only, we can understand population versus sample. When you in inferential statistics, for example, we are to conclude whether the marks scored by class 11A, the average marks scored, is more than the average marks scored by the entire school. So the entire school here is the population, and the marks scored by 11A is the sample. So the bigger circle, for example, this bigger circle is the entire school, and the smaller circle, say, for example, where did it go? Yeah, say we have 17, 18, 19, 12, 13, 30, wait a minute, 14. Okay. So, for example, this is it there, and then you have another value. This is 12, 15, 16, uh, 12, 15, 16, 17, 18. Okay, like this you have another values and values and values. So like marks code. Okay, and say this is the marks scored by the entire school, average marks scored, and this is the average marks scored by just class 11A. So here this will be the sample size. Let us, sample size is always denoted by small n, and this population is always denoted by capital N. So this is the population, and this is the sample size. So I hope you understood what is sample size, what is sample, and what is population. I'm sorry, I told sample size before. It's sample and population. Now what are the various ways of taking a sample? Here we randomly took, okay, no, here we took on the basis of a condition that this marks code should be of class 11A specifically. So that is a type of sampling. But for example, I can take this marks. Okay, this whatever this is. So here I am doing random, simple random sampling. So there are four ways of taking out samples from a population. Now we are going to discuss those four ways. So let me write down the topic. Four ways of taking sample, and I again have a photo for that. I think visually when we understand something, it's very easy. So 4 ways of taking sample. Yeah. So let me just paste it. Yeah. It's not visual, but yeah, it reduces my work of writing. So, okay, I'll draw the visuals myself. Don't worry. Okay. So, what is simple random sampling? So, as I explained you this entire thing, uh, let me read it out, then I'll explain the names of say here they are taking example of children's in a middle school, and they are doing some voluntary activity or something, whatever. Okay, so simple random sampling is the names of all thousands children are placed into a computer database. The computer is then instructed to randomly select 100 names. These children and their parents are then contacted. If you're familiar with Python, there is a random module. Same thing. It draws, what it does is, when in, for example, rand range, we use the rand range function in Python. So here we give it a starting value and an ending value. So what it does is, from this population it takes out a sample. Okay, random sample. So that is what simple random sampling is. The second is stratified random sampling. So what we did in stratified random sampling is, now there are some conditions for stratified random sampling. Let me explain to you stratified random sampling. So stratified random sampling, there should not be overlapping. For example, there is a population, so for example, population of Assam. Okay, and we are taking samples of males and females. Now they will not overlap. Now, for example, say this is the population of uh, Assam, okay, and population of Assam. Where is the drawing tool? Okay, and say for example, and this is this is female and this is male. So this will not overlap. Okay, there will be no middle thing here. The We are taking samples based on strata. This is one strata, that is male strata, and this is female strata. I hope you're understanding what I'm trying to tell. Here there will be no when we are taking the data set, when we are taking the sample from a population, there will be no overlapping. So similarly, hundreds children are placed into a computer and organized by grade 6, 7, 8. Now there will not be a student who is in all the three classes or two classes. The computer will be randomly selecting from a strata. Okay. So out of this males, I'll select some. This is my say small n. Okay, this is my capital N, this is my small n. Again, this will be my small n. Say, let this be N1, this will N2. So the sample in N1 and the sample in N2 will never be same. So this kind of sampling, when we do, it is called as stratified random sampling. I hope you understand this much. The third is called the convenience sampling. Okay. So what happens in convenience sampling is, only people who are interested, interested is not the right word, only people who are uh, like required for our data set. Okay, for example, if we are taking we want a data set where we are making a machine learning model to analyze the brain tumor sizes and detect whether this person will live or not. Okay, so here the sample size out of the population will be only the people who have brain tumor. So there is a convenience we are putting it. There is a condition, there is a straight out condition that this will be the only people that will come in our sample size. So out of the population, you are taking this many people out. That is known as convenience sampling. For example, here the researchers known one of the middle school teacher, and the teacher volunteers are 35 students for the study. So only this middle school teacher student will be taken for the study and no one else. you you're getting what I'm trying to say. What happened in stratified random sampling is, out of a population we are dividing that, okay, this will be one strata, this will be another strata, and then we are taking out the sample. Here the sample is random only, but it is inside a strata. But in convenience sampling there is no strata, there is like a topmost condition that has to be followed. There is no random sampling, there is a convenience sampling. So that is the difference between stratified random sampling and convenience sampling. Now it is very important for you to understand this, because it depends on the sampling that what statistics the concept we are going to apply when it comes to data science. Okay, for data science people, it is very important to understand what the concept behind the code is. For machine learning and deep learning, it is more important to understand how modeling is happening. It is not very important to dive into mathematics. Even if it's one wants to, they will first, if the interviewer wants, if someone wants to test your knowledge, they will ask the question more on calculus part for deep learning and machine learning. But for data science, you have to understand that these concepts are something that are going to be asked to you in the interview. The first question they will ask is, what is the difference between ordinal and normal data set? So things like that you need to understand. That is why I am emphasizing this first video solely on terminologies. From the second video, I'm not going to focus on all this, and we are going to straight out go into advanced topic. We are going to see a topic, we are going to see the example, we'll move on to the next topic. We are not going to visualize and do everything with all that. Okay, so I hope you understood till here. So let us revise what we have covered till now. What is statistics? What is probability? What is the difference between descriptive and inferential statistics? What is sample and population? What are the different ways of taking a sample size? So the next topic that we are going to be focusing on is variable. Now, people who are from computer science background, they know what a variable is. But for people who are not familiar what a variable is, so there are two kind of things in this universe. One is constant, one is variable. Constant thing is RCB not winning IPL. That is constant. Variable thing is, will CSK win this IPL or not? I'm sorry to RCB fans, but yeah. So variable is something which can take a value. Okay, variable is something that is like an empty jar where we can put something. But constant is something that is a packed. A packet of biscuit is constant, but a empty packet of biscuit is not constant. An empty packet of biscuits, you can put cake inside it, nobody cares. So that is what variable is. A variable is a property that it can take any value. Okay, now there are two kinds of variable: quantitative variable and qualitative variable. Let us note that down. So we have quantitative variable and we have qualitative variable. Qualitative variable. So what is quantitative variable? Now quantitative variable is something that is uh, there are two conditions. First, it can be measured numerically. Second, mathematical operations can be performed on them. For example, runs scored by Virat Kohli in a match between RCB and KKR, in which RCB scored. No, let's get up from IPL. Marks scored by Vishal in class 11 annual exam. That is a quantitative variable. That mark scored is a quantitative variable. First of all, it is numerical value. Second of all, we can add it, subtract it, multiply it, divide it. So that is the condition for quantitative variable. Let me see if I have a photo for it or not. I don't think I have a photo for it. Oh, I have. So let's copy paste it here. So yeah. So quantitative variable is, it can take numerical values, and something that is missing here, it performance things like addition, subtraction can be performed on it. Whereas qualitative variables are something that are not numerical. For example, uh, I have to take a random name of an IPL team. Name of an IPL team here is a variable, and the value that I can put here will be CSK, RCB, KKR. So these values are not numerical. Performance of arithmetic cannot be performed on them. So that is why they are qualitative variable. Whereas quantitative variable are numerical values, just like my marks, and values, arithmetic operations can be performed on them. So I hope you understand what is qualitative and quantitative variable. Now we are moving out to, okay, now we'll understand one more very important thing, and this is very important for you to understand. Now this quantitative variable can again be divided into two parts, okay, that is concrete and continuous. And I have a photo for that, and the photo will itself explain what is, the word itself explain what I mean, but what is happening, wait a minute, yeah. So you have discrete and you have continuous. So let me take the photo, yeah. Yeah, so discrete data can be marks scored by Vishal in his exams. Okay, this can be discrete data. Now, what can be continuous data? Percentage of Vishal from class 1 to 10. That can be an example of continuous data. So, I think it's clear. Continuous data, like, and again, another important, very important thing is discrete I'm so sorry. Here, the image specifically talks about data, but when it comes to variables, right? Discrete variable will always be numeric values, and continuous variables may or may not be numerical values. For example, percentage of mine from class 1 to 10 cannot be numerical values, but my marks has to be numeric values. Okay. We are considering here that my marks are numeric values and it's not in decimal. So that is the difference between discrete and continuous data. So the next topic that we are going to see is the last topic for today probably, and the topic is, I have another photo for discrete random variable and continuous random variable. Let me paste that so that in the notes it's very easy for you to understand. Yeah. So again, countable set. Okay, again, discrete can be countable, but continuous random value is from an interval. For example, my marks can range, my percentage throughout the years can range from class 1 to 10. So class 1 to 10 is the interval, whereas my marks, it can be anything, right? Like in a single set, you have to have concept of set. My marks can be anything, but here we are using an interval. Okay, it can be this, it can be this, or it can be you know, it can be this. So this is interval, and this is, for example, in discrete you can express it using a set. In continuous you can express it using an interval. Okay, so that is discrete and continuous data. And now we are coming to the last topic for today, and that is the four levels of measurement of data. And this is very important. Okay, I'm telling you, this is very, very important for you to understand the different types of measuring data. First, what did we see? We saw the different types of taking sampling size, but now we'll see what are the different types of measuring data. Okay, so let me just find the photo. My desktop is very badly arranged, that is why I'm not always able to get the data. Photo, yeah, I got it. It's not a very hard concept, but it is important that you remember these concepts throughout. Okay, because for example, yeah, you'll be needing it at every step when it comes to data science, because if you don't know what kind of data it is impossible for you to even proceed with 10% of your project. Okay, so types of data, let us, let me make it bigger, and we'll paste the photo, and then I'll explain it to you. Don't worry. I will just not paste the photo and read it out. But the photo is explainable in itself. So what are the four types of data, or four types of data? How are we measuring it? So there are four types: are nominal, ordinal, interval, and ratio. Now, nominal and ordinal are something that is easy. Interval is also easy. Now you need to understand that ratio is something that is very not, I mean, it is rarely used, but when we talk about nominal, ordinal, and interval, nominal is the, like most of the data you find on the internet is nominal, followed by ordinal and interval. So nominal and ordinal can be explained by simply by, for example, uh, we have to this, and say we have marks, and we have 20, 30, 40. Okay, say a mark scored by students, scored by students. Okay, so you have marks scored by students, and you have their ranks. Say 3, 2, 1. Okay, so now this data, marks scored by student, it has categories, and there is not it doesn't matter whether it is ranked or not. It just has to be numeric data or even quantitative data. No, it is qualitative. I'm so sorry. It has to be quantitative data that is there. I mean, that is just there. There is no rules on how it is arranged. It is raw data. Like you have not performed EDA on it. EDA, I think when we cover the next 2, 3 videos, we are no on the final video we are going to do EDA, that is exploratory data analysis, on a machine learning project, and we are going to perform all the concepts that we learned from the next videos itself. This is just a terminology understanding videos. We are not here learning some concepts, but we are just understanding the terminologies that are related in statistics. From tomorrow onwards, the real statistics, the real things that we are going to use in our code begins. Okay, so today is just an introductory and terminological video. I don't know if terminological is a word, but anyways, yeah. So this here is our, oh my god, my mouse. This here is our nominal data, and this here is ordinal data. Ordinal data is where the ranking of the data matters to us. So here it is 3 to 1, that is decreasing order. Okay, in decreasing order the ranks are given. So here we don't care whether आपको 20 if you have gotten 20 marks, 40 marks, 60 marks, what is your rank? The rank is mattering to us, not your marks. But in nominal data, the raw data, the marks is mattering to us, not the rank. So that is nominal data, and this is ordinal data. I hope that much you have understood. Now, what is interval data? So a data that is followed in some interval. For example, marks scored by students from 10 to 20, 7 students, 20 to 30, 13 students, 30 to 40, 15 students. That is interval data. And ratio data is where the data is following some kind of ratios. For example, the marks scored by 10 to 20 students was 2, 20 to 40 students was 4, 40 to 60 students was 8. So here a ratio is being formed. A geometric series is being formed. A geometric series is the best example of ratio data. You understand that? And then interval data, there is intervals, but not a ratio is not being formed. Okay. On ordinal data, there is data, but the rank of the data matters to us, not the data, not the actual data. In nominal, the actual data matters to us. So those are the 4 levels of measurement that we are usually used in data science, not data science, statistics. And that was all from today. For today from my side, it is just an introductory videos. I wanted to keep it less than 40, 35 minutes, so that you watch the video, you learn the concepts, and that you are interested in learning more. Okay, this is just like prerequisite for even starting statistics. The real statistics will begin from tomorrow onwards. Okay, so tomorrow onwards we are going to cover statistics. I think the second video will be statistics plus some amount of probability. The third video will be complete statistics. The fourth video will be practical applications. So in 4 videos, we are going to cover entire statistics and probability that you need throughout your data science, machine learning, or deep learning career. Okay, so that's Vishal Kumar Jha from your side. This was the first video. Even this is my first time trying to start a series, and I hope that I continue with it and I complete it, and that I don't know whether people are going to watch it or not, but I'll try my best to explain the things in the best way possible, and it works as a revision and a learning process for me also. So I hope that you like the video, and thank you so much for being throughout the video if you have been till here. And I hope to see you again tomorrow in a new video. And if this series is successful, I am thinking of, as I told, the calculus will be part of the deep learning series. So if the first two segments are completed successfully, I will start the third series. And the third series is going to be amazing. We are going to cover a lot of things. We are going to do amazing projects there. And before that, I really hope that we complete this series of mathematics required for machine learning, data science, and deep learning. So thank you very much, everyone. This was Vishal Kumar Jha.